Hello and welcome to this webinar, a NextGEOSS webinar. My name is Bente Liljaby. I'm going to be your host today, and we are going to learn about QGIS for Earth observations. Before we start, and before I start to introduce the speakers, I will tell you a little bit about the program. First of all, you will have a very brief introduction to what QGIS is. A visualization tool. Is free and open source, so some of you might have heard about it and some of you haven't. But anyways, it's a free and open source for visualization of data, and we are going to use Earth observation data. Now, Earth observation in this context is actually both satellite-based Earth observation, so remote sensing, and in situ gathered data. So that's Earth observation in general, but you will learn that we are focusing on satellite-based, and more specifically, the type of satellite data will be introduced to you. Now, today first the introduction, and then we will show you a excellent, literally a cool example from sea ice, and so that you can see how it's being used. So that's the two portions of the webinar. You will be you will be encouraged to ask questions along the way. So we have the chat box to the right-hand side of you, and you will be able to ask questions and comment there if you like. We plan to do this in about half an hour, depending on how active you are. If you have many questions or many comments, which we welcome, we can do this for about an hour. So I will start off by semi-introducing the speakers or the speaker today. And the way we do it is, my trademark on webinars is to do a weather report. So first of all, we do the weather report. And Mohamed, can you tell us where you are and what the weather is like where you are?
Thank you very much, Benta. My name is Mohamed Babiker. I work as a research scientist at NERSC Center. I done my PhD 2004 in hydrology in arid land, but now since that time, I moved to the cold regions. I have been working mostly in the polar regions, mostly with satellite data and geographic information system analysis and presentation. Now I am based in Bergen. The weather in Bergen, maybe a lot of people know about that, but it is raining as usual, and I feel it is strange. This year we don't have snow at all inside Bergen, and that is it from my side. Thank you very much.
Thank you, Mohamed. And I will ask Torill as well. I will ask where you are, even though I know. I will ask where you are, what's the weather like, and who's helping you?
And who's helping me? Yeah, that's a big question. Well, my name is Torill Hamre. I also work at the NERSC Center in Bergen, Norway. And the weather is, as Mohamed said, quite Bergen-like today. Well, here in Bergen, it's not raining cats and dogs today, but you see this little guy over here. He's... well, this one is kind of safe, but it's a reminder that in the Arctic regions there are also other things than sea ice, among other things, polar bears, and they are nice when they are like this, but they are a real thing to consider if you find yourself in the Arctic.
Absolutely.
So that's the short weather report.
Yes.
I'm a computer scientist, and I worked for many years with different kinds of mostly marine data, a little bit with in situ, and then also with remote sensing and modeling data. Now I work mostly with making data and derived products from these sources available online to spatial data infrastructures and data repositories. So I think that was quite brief on the weather.
On you guys.
And,
yes.
Yeah, on us. That's
yes. You and your friend.
You and my friend, yes.
Yes. And well, of course, your friend is benefiting from sea ice, right? It's actually something very popular for the the polar bears, of course. We know that.
Definitely.
So, yes. And with that, I think we can kick off this. And the way we do this, by the way, is that I want to encourage you to write your weather report. Tell us where you're from and what the weather is like where you live in the chat box. And then this way you get to know our tool. And we'd like you to ask questions about QGIS and the application also during this webinar. So go ahead and write us. Hello, Abdullah and Gabriel. Good to have you here. From Bangladesh, imagine that. So far away from the polar bear regions, huh? But you can use QGIS, and you will know that, and you will learn that you can use QGIS wherever you want on this planet. Mohamed, can you introduce us to QGIS?
Yes,
what is QGIS?
Yeah,
Let us hear it.
Presentation and
oh, hello, Luan from Vietnam. So many people from far away here. Great. So Mohamed, he will share his screen, so the presentation will be there, and you will be able to get his slides afterwards on the NextGEOSS website, nextgeoss.eu. Now, here he comes.
Here we come now, and yes, let me put it in, yes.
And we will turn off our cameras, but don't be afraid, we will return when Mohamed has introduced us to QGIS. And you get it into full screen mode, Mohamed?
Now I'm trying to do that.
Yeah.
Now is that there now?
Yes.
Okay.
Perfect.
As I mentioned, my name is Mohamed Babiker. It's written here. I'm from Nansen Center, and I think Bente gave a kind of a little brief about what we mean by Earth observation data. Today we are using mainly product from satellite data. So it is not a satellite data itself, because here you can range it in level. It is level 3 or level 4, because there are two products here we have. One of them is from NextGEO and the other one from CMEMS. So both of them based on satellite, but they are not satellite data itself. So let us go for the presentation now. And as Bente said, I will try to make a kind of very brief about QGIS. Maybe a lot of people using it or they use part of it, but here I will just introduce QGIS. And we can say, why QGIS? QGIS is a free software, so you don't need to pay anything for it. It works for cross-platform applications, means that it works for Windows, it works for Mac, it works for Unix. So all these programs, all these software, or all these operating system, they can use QGIS. The other thing, what is it? It is a geographical information. So it's based on geographical information. It means the data is to have a geographical location, or the same like other geographical information system, it's based on coordinates. Good thing about QGIS also, it imports different data format. Number 3, it exports different data format. Also, it works with raster data, gridded data, or with vector data, which is points, lines, and polygons. I put also here where you can get it. You can get it directly from the home page, that's downloadqgis.org. One of the things that we mentioned also, it is open source. It means you can contribute it. So there is everybody can contribute, and that is the reason when they release it, the version here released according to the date of the release. So for this tutorial, we are using 3.8. When you are starting this, there is 2 ways you can start QGIS. If you are a beginner, example, somebody give you a complete project that includes everything, so you just click directly on the link he sent it to you, or on the file he gave it to you, and usually it is ending, or the extension of the file is QGIS. This is one way. The other way, you click on the icon of the QGIS in your desktop, and then you start to load your data file by file. The nice thing about when you get a project ready, then all the data is there, or the data here, where I mean, it is the layers. And the other thing that also, one of the main thing, how do you define the coordinate system you are using? I will come that in details when we are presenting our data here. So here we have, when we click, like now we got the link, you can see it on the screen here. That is, if you just double click, you will get something like that. It is the map showing Svalbard in the middle, Greenland in the left, according to what I see in the computer. And you have on the top here, you have Franz Josef Land. What the map mean? That is the sea ice concentration map. The dark blue, that is water, and the rest is ice with different kind of concentrations. Two things you can do. If you go to project and you see the properties of the project, you will get a window which will describe many things, or you can find a lot of information. Example, in general, you can find the project file, where it's located in your disk, and also use the project name, metadata about the project, and the most important thing, also you can find the coordinate system of the project. Okay, now we have a project with all this information, and if you look at the lower part here, you will see the layer that we saw, which is the ice concentration. If you also click on the right click and then look at the properties of the layers, you will find a lot of information about the layer itself. Example, it's presenting ice concentration, that's the coordinate system, and then you have the extent of the data, how many bands, what kind of units, how many pixels, like width and height. This is one part. If we go to the homology, you will get how do you here you color your data, because I mean, like any kind of product, they have to have a kind of a special color range. So according to that, here you can play with that. Also on the top here in the render, how do you present this data, or how you want to present this layer? Is it multi-layer, like more than one band, so you can present it in like RGB, or also it is one band layer? Also here you define like the color you want to use, and also here you can like visualize and play with the histograms and the transparency, if you want to remove the transparency from the layer. I think that is it for the just small introduction about the QGIS for the people whom they don't have background about it. Back to you, Benta.
Thank you so much, Mohamed. This was a great introduction. I have been hearing about this tool for so long. Can you come back to me, both Mohamed and Torill? So, and but before we go on, thank you so much, everybody who are giving us weather reports. And I see that you come from all over the world. I'm amazed. So thank you for joining us. And you also tell us where you come from, you know, in terms of institution and so on. So we have people from Svalbard here, by the way, and we have people from Bogota in Colombia, Israel, south of France. This is fabulous. Yeah. So welcome. And thank you also, Mohamed, for this introduction. Myself, like I said, I heard about it. I want to test it out now because I feel this is approachable tool for people that are not normally even working with data, like developing algorithms and so I'm very excited about that. If you have questions now to Mohamed about QGIS at this level, please write them in the chat box. I will read the questions, and if we don't have time to answer it right now, we will have a Q&A at the end where we can pick up some of the questions that we are not able to answer exactly now because it's a little bit of delay and so on. So please do ask us questions. I did a little poll. I don't know how how many of you have answered, but it looks like most of the people have experience from QGIS, but there are also some novices like me. So I think that's an interesting observation. So I'm not alone. That's my observation. We're not being used to.
I think for the people who have been using the GIS, we are just here very, very, like we are very simple applications, but the data, maybe it will be interesting for you that to look at it.
Yeah.
The data we are using.
Yeah.
But,
so now,
yes, the application are really simple.
Yeah. So now you will. So now you got a very short introduction to what QGIS is, and of course you will learn much more now than when Mohamed will take you through a very cold case, the cold region case, and he will use CI's data. Since there are several here who has already experience with QGIS, I would like to know what type of data that you have been using QGIS for. Now, we, as you know, in the announcement of this webinar, you were informed that we are going to look at CI's data, so up far north normally, but there are many, many other application areas. So for disaster management, for land use, for agriculture, and so on. And then you use different types of data. We are using Copernicus data, so from the European Earth Observation Program, producing a lot of satellite-based data, and also in situ, by the way, and models, but a lot of satellite data. And those are free and openly available. So just to plug that one. But you have Landsat from the US, which has been pouring out Earth observation data from space for many, many years now. Yeah, so Jorge Samuel is saying web services access and land soil properties. There you go. That's another application area. And yeah, so I think with that, I don't see any more questions right now. Do you have something you want to add? So Torill is here, by the way. She is leading the NextGEOSS pilot called Cold Region, where CI's data is one of the important ingredients. So if you have questions related to her use of that in Copernicus, she will be able to answer. Do you have anything else to add? You had something, you have experience using QGIS, Torill?
I've used it a little bit, but not as much as Mohamed. But I think it's quite easy to get started with. And there's also this nice feature that even if you don't want to or know how to program additions yourself, there is a list of community plugins that you can install in addition to the core functionality that you get when you install QGIS. So there's quite an active also developer community, and they share the plugins through this QGIS.org site. So there's really a lot of help to get, both in terms of documentation, but also in terms of actual pieces of code that you could use for your kind of data.
Yeah, that's interesting. This is my impression also. So now we have some question. Raphael, asked, in the presentation you have different colors on the map. All colors mean different types of terrain, for instance, ice and water, etc. There is a range of colors in the setting. What is the reference? How do you know that a particular color means a particular type of terrain?
Thank you very much. We are not presenting terrain here. We are presenting, you will see it more in details when we are presenting the rest of the presentation. Here it is ice concentration. Yeah,
but how do you know it's the index of the color? Yeah.
The index of the color, there's some like international organization, they call it ice charting group. They give colors according to that. So you can pick what kind of color and you can introduce them in QGIS. But here I will present it later, show you like what each color mean.
Yeah, okay. So Raphael,
it's not. Yeah, I used to work with Raphael. I used to work with DTM and something like that. So it is very common to give it according to what you have. But here we don't present DTM. It is the ice cover and its ice concentration. You have different concentration of the ice. Since you move from the water up to the what they call the fast ice, which is in Greenland example, you have different concentration on ice. They are the kind of very simple. The calculation for it, how they calculate it. They take a square area and they define the percentage of the ice according to the water.
Right.
So that is what they have on that.
Right. So there is some sort of standard for that as well. But
exactly.
Yeah, and this is also handled by QGIS, but you can, in principle, I guess the tool allows you to give a color, a parameter, any color you like, but there are some standards.
Exactly. Yeah. I mean, depending on the standards for what you are presenting, you should pick that. But QGIS gives you the wide area that you can pick the color you like. I mean, if you want to make it what you like, that is, yeah.
And I got a comment from Anastasia, and she's a forestry environmental consultant. Yeah, so yet another application area. And she's using numerous types of data in her work. Furthermore, she has worked a lot with Sentinel-2. Yay, that Sentinels are one of the Copernicus satellites, for those of you who don't know, and the production of indices such as NDVI and bird area index, etc., during her master of science thesis. And she's using OpenLayer plugins in QGIS. So that's an example for you. So thank you, Anastasia, for sharing that with us.
That's really interesting.
Yeah. Okay, so Raphael got his answer. Everything is cool. I think we are ready to see the example. Mohamed, can you?
So let us navigate to the Arctic now.
Yeah. So we will, and you can ask questions all through when you're listening to Mohamed. Please do ask questions, and we will ask them. Read them and ask them at the end, at the Q&A. So don't be shy during the presentation as well, when you have the question in your mind. And yes, I think we are. How are we doing with the sharing? Do you find the document again?
I am looking at it now.
Yeah, terrific.
I'm trying to find it again. As usual.
Yes, this is so. Yeah, let me see how I will give you while we are waiting for Mohamed to find. So I see that 75% more precise the poll if they're using QGIS. 75% of you have already used QGIS, and 25%. You are just like me. You have not used QGIS. Okay. Do you find the buttons?
Now I'm looking for the share things.
Yeah, so the share is in the top, the middle, beside the microphone. So this is a. Meanwhile, Usama asked, can we perform time series analysis in QGIS environment? And Torill, I will ask you that so Mohamed can concentrate on sharing his screen. Have you used it, Torill? You need to unmute yourself, Torill.
I haven't used it for time series analysis, but I think if it's not part of the sort of the core functionality, I'm quite sure that you would find a plugin that is able to do it for you, or to find examples online of people using QGIS. And I also forgot to say that there are QGIS user groups in many of the nations, not only in Europe, but around the world. So there's also a chance that there are other users in your country if you don't find any examples sort of centrally in this QGIS.org site. But I think this is a common kind of operation that you would use for land, for marine, and for many types of data.
And time series is definitely a hot topic, and I think for the cold region pilot, which I'm also involved in that, I'm not doing anything technical except trying to understand what people need, and having time series of the sea ice development is something that is really interesting for end users, right, Torill?
Yes, that is of course critical whether you are looking at longer timescales and you want to look at how the changes more on a climate, or if you are actually near the ice edge and you want to either you want to find the easiest way into the ice, or you want to avoid the ice altogether, depending on your vessel. If it's not ice strengthened, then you want to stay safely away from the ice edge. If you have some level of ice strengthening, then of course you can go a bit into the ice, depending on your vessel, but you're still looking at to find where are the leads, where are the thinner ice, where are the openings that you can go within to save time and to save fuel, and also to make a safer journey. So following the ice development over time is very important. That is a key issue, and for that matter, then satellite data is very suitable because you can get daily products, and that allows you to get updates on how the ice edge is moving, because it may be driven by the wind conditions, and it may change very quickly. So that means that you really have to be alert and keep track of the conditions when you are navigating in these areas in the Fram Strait, and if you go north of Svalbard, or if you go close to in the Barents Sea and then northwards towards Franz Josef's Land, then it's the ice is a critical issue. Yeah. Not only because you may run into one of these, but I think for a vessel, it's more.
Let's have a look at your friend again. Yeah.
Yeah. He's a nice specimen of the species.
Yeah.
But even if you're on a vessel, then you need to be on lookout for polar bears. Mm-hmm. And if you move onto the ice, for say if you do sea ice measurements, then you always need a guard. You don't just go up on the ice by yourself. There's always somebody on the watch with a rifle, because they are, well, to a polar bear we are something.
So sorry.
Yeah.
Just a minute. I think I have to do something.
Okay. You lost your presentation. No, he's. So we are. Apologies for the technical challenges here, but you will get an example from the cold region. Meanwhile, I can ask you. So for those of you who have used QGIS, it would be interesting to hear more about what type of data you have used it on. So now you heard, and you will learn more about the usage of sea ice, or how we can use QGIS on sea ice data. But it would be interesting to see what you have used as well. So I will write here so you can answer this. What type of data have you used with QGIS? I see that already somebody is mentioning, what did I see? Yeah, well, openly.
There was somebody who worked with vegetation indexes.
Yes, right. Somebody from forestry using Sentinel-2. And okay, so here Usama is asking, are there any statistical toolkit in QGIS that we can use to derive some spatial statistical indicators for sea and ice? Have you bumped into that, Torill?
No, but again, I think I would look up on the on the plugin list, because again, such general tools is likely that you would find either a plugin, or that you would find sort of other people working with QGIS, and that can do. I'm looking at a few of the plugins. There's some on clustering, and
more. Maybe we can bring that up again, because now we see you are you're back, Mohamed. Great to have you back. We will disappear and we will learn about more detail on the sea ice data use.
Okay, now everything you can see that.
Yes, we can see it.
Okay. So sorry for that, because that's normally technology. It happens now and then, but when people are waiting, I am really apologize for that. Now we come to the main thing here. We are comparing sea ice data from NextGEOSS and CMEMS. CMEMS, that is the Copernicus Environmental Management Services. They have a catalog, and NextGEO have a catalog. Our presentation, or how we will go through it, we will first search data, download it, then visualize it in QGIS, make very simple analysis for the people who are really experienced, comparing the two data sets, and then making maps from that. So for the NextGEOSS, here we use the thread, which is already offered by Nansen Center. And on the red box, you see the 3 images. For the people who are familiar with Sentinel, that's Sentinel-1B. Sentinel-1 is used, it is the SAR, the synthetic aperture radar. So it uses the microwave from the C-band. The data here is product based on these images for producing a classified images for sea ice and water. The algorithm we developed here at Nansen Center, it can run automatically for huge amount of data for whole Sentinel-1A and Sentinel-1B. So let us now download these 3 files. All of them are from the 23rd of July, 2018. And you can see the extension is NetCDF files, and that is very common now for distributing a lot of data, because it is very handy for a lot of people. The other data is from Copernicus, from the Copernicus Marine Services, and that is the homepage you get to when you just copy and paste the links that I have it on the top of the slides. For downloading data from this site, you have to register. But browsing the data, there is no problem to do that. As you see, we have 3 boxes. We have ocean monitoring indicators, and we have state report. If we click, because we are interested in ocean data now, if we click on the green one here, then we will get to the page. You can see the number of products here is more than 174 ocean products. On the left part, you have here, you can define the parameters or define the region you want to download the data from, and also what kind of data you want to download. We go further. Now we define the region, the Arctic Ocean here, and then what we need parameters, we need sea ice. And then we have the product that we are looking for. In the lower part, you can get more information about the product, or you can add it to the chart. It is free of charge. I mean, you don't need to pay anything for downloading this data. Just it is a part of the system that they know who downloading it and how many downloading it and what they are using for. That's the interesting part for the organizer for this. After downloading the data, now we need to visualize it in QGIS. As I mentioned at the beginning, usually if you got a project ready, you just click on it, you will get directly to the layers, all the layers. But here we start from scratch. We just double click in the icons of the QGIS. We open QGIS now in front of us. The first thing you need to define the coordinate system you want to use. And since we are downloading data from the polar regions, we have to not to depend on the system that is or coming, because it can be any kind of, you will project the data on the right place of it. So here we choose North Pole historiographical, and there is many project systems available in QGIS. You can define the according to what and where you work. So we usually go to properties, and then we in the project properties we define the coordinate system. Then now we are done. We have done that. Now we go back again and then try to open the file. When you are opening an SCD file, it is really important to know what exactly what layer you want. Because, example, if you look at when I downloaded data from CMEMS, there you can define the date of the data from that time of the period of the data, from special day to I mean like how many days you want from the data. Depending on the size of the file, you can download it directly or you can download it in part, because they have a limitation on how big the data the file can be. In this case, I mean like you can download several days of ice chart. What I mean here, this layer is the ice chart or ice concentration chart. So you can download different layer. When you are opening the GIS, you need to know which layer you want to open. So this is how it looks when you first visualize the data or the NERSC file that we just downloaded from the CMEMS. Now we need to go to the properties of the data, the properties of the file that as I show at the beginning here. I will right click and then go to the properties. I will get the window that I can define the color, how they should look. I can rotate the image, do what I would like there. And the most important also on the top of when I say the rendering or which band you want to see, because here you will get all the days. The software will pick the top one, but generally you need to know what date you want. So here we are using the data from the 23rd of July. That is the same images that we downloaded, or the same product that we downloaded from NextGEOSS. Now we have 3 files that I said downloaded. That is the same here. We put all the files. You can see all of them. There are 3 files, which is 3 tiles of images. They are laying now on this from the north to the south, and that's according to the motion of the satellite. It take it, and each one is 500 kilometer west, and it will go down like that. So that is from the same day. The difference can be seconds between these images. I cannot do the same thing that I have done it with the ice chart, the one that is downloaded from CMEMS, because here we have 3 layers. It is possible to go one by one. Instead of going one by one, I would like to make them all as one image. Instead of taking one by one image and take the properties of each image and fix it, because maybe I will not be right. So according to this, we will merge. That's a very simple processing. We will merge these 3 images to get one file. How we can do that? There are steps, clear steps. First of all, I will save all the images because as I mentioned, they are NERSC files. I will save them as duty files and then export them and save them as new files. After that, on the top of the program or the software, I will go to new processing toolbox. I will search and locate the GDAL raster, and then I will go merge tool. Then I will get a double click on that, and then I will get a window where I can define all the specific parameters that I would like to define. The type of data, where the file should be saved, and what kind of format. Here we have done that in TIFF. And now you can see we get only one file. I didn't mention the color because I think Rafael asked before. You can see that the color here, 0, that is water, 0 concentration, and then I have 25, and then I have 50, and I have 75 and 100% ice. That is the top of Greenland, and that's very common according to the sea ice for this area. And now we have these images, all of them in one file. So we have 2 colors only. We have ice, which is white, and that is also in nature like that, and the dark is water in the image. The black color is water in the image. Then now, for comparing these 2 data sets, one of them can be visualized, like I can look at it, like visually compare them, or the other way that and that is by using the contrast of the images, or the other way that I create a shapefile. For, I think people know shapefile is really famous vector layer for people using geographic information system. And in definition, shapefile can be points, can be polygons, can be line. So what I will do here, I will draw a line on the top of images and compare the line with the chart underneath. So let us go to the image contrast between. Now we just removed the, we just give the water the same color as the water available, or the same color that presents the water in the ice chart. Then now we will try to play in the contrast or reduce the transparency on the top layer. We have done it like the same. We took like 100, this is 100 now, and then we make 50, 75, 50, and 25. So how here we look like the product from this, like when I increase the transparency of the top layer, and how the two layers are matching. Is that interesting for us? I can talk about that later, why we want to match them, because these two products are produced in totally different way. One of them is produced from a lot of satellite and human intervention is a lot of it. The other one is completely automatic. The script written in Python for classification. You just put the image and you will get it classified to water and ice. Now we go to the next step, that is to create a shapefile and then draw the line. There are several ways you can create a shapefile in QGIS. You just go to the menu layer and then create layer, new, and shapefile. Or you just click directly here where you can create a new shapefile. Then a dialog box will appear. Also, you need to define the specific or specification of the shapefile you want to create. Example, first of all, here we will not pick, because you have 3 categories you can pick from. You can pick point, you can pick line, you can pick polygons. We will pick a line, and then the specification of the line, or the how it looks, color, thickness, and all these. What we do after that, then we will start to toggle or to start to edit by clicking on the kind of a pen on it, and then we will zoom in and out and try to trace exactly where the ice edge from the images that is downloaded from the NextGEOSS catalog. And we will continue with that, and we will reach this. This is how they look, the line we draw from the beginning. So now we have on the layer window, we have 3 layers. We have the ice edge on the top, that's the shapefile vector layer, and we have the image, and we have the ice chart underneath. Then we remove the images, and that is how it looks, the line or our data that brought it from NextGeo and put it on the ice chart. And I think there is a lot of matching, and we can be confident about that. There is small things, there is small variation in some places, but I mean that is very common because of the processing procedure. I mean, the ice chart is processed from different satellites. The other things also, there can be variation in time. The ice chart, the ice edge where the line is very dynamic, and it's really important. Maybe Torill and Bente mentioned that. Why we want that? There's 2 ways you can think about it. First of all, from application point of view, navigation, a lot of ships, they are not allowed to come beside the ice because of their category as a ship. They should not be there, because it can be a lot of damage for the ship and for the people on board. The other part also with this kind of measuring where the ice is, also it's more climate, because each year, like people thinking about how big is the ice in the Arctic and how that will influence the climate system in the world. The last part, how you make a map from that, then it's also straightforward for QGIS. You just go to the main menu. You will have new print layout. You define your print layout here, and then you click OK. You will get another window or another smaller layout from QGIS, and then or in the layout in the top here, there is the add item. You just add item, and then you say add map. Then you take your window and draw a rectangular on the layout. Then the maps, which is you see it on the main QGIS window, it will appear here. So it will appear like that. Then it will be the normal way how to add the most important thing in each map. You need to have a title, you need to have a grid, you need to have a scale, you need to have a grid, you need to have a scale, and you need to have any kind of other information you would like to add to the map. So this is the whole thing that you can add. You can add grid. One example, when you're clicking on add grid, you will get a window. You specify all the information you need about grid, the spacing, the thickness of the line, where they should start, where they should end. North arrow. Also, you have different north arrows samples you can pick from them. Scale par. Also, you can define your scale par if you need it in miles, kilometers, how big it should be. Then the legal order will be imported directly, and any other information. So it will look like that. Now you have a complete or a ready map. It can be used in any document, reports, or publication. Then what you do, you just go export as image. And as we mentioned at the beginning, if you are happy about your map, you create it, you just export it as an image. And there's several formats you can export: PNG, JPEG, and others. You can export it also as PDF files. Then this is what you will get. Now here also I added the line that we draw. I think that is what I would like to know would like you to know today. If you are interested, then we can go back to the question and answer and see. Thanks very much.
Thank you very much, Mohamed. This was very interesting and enlightening, and please do ask questions right now if you would get into more details. I was trying to follow on, and so NextGEOSS, by the way, for those who are not that familiar with NextGEOSS, is a European data hub and platform. So we have a catalog of data, and a lot of Copernicus data is cataloged already. So Torill and Mohamed in the cold region pilot, we have cataloged these data and also some products. Torill, can you, this is one of my questions. So you did developed a algorithm for the CI's edge, right? Or the classification?
Yes, that was the second product that Mohamed showed, which is shown as an ice water classification of Sentinel-1 SAR, and that was an algorithm that has been developed here at the Nansen Center, and in NextGEOSS it was run in a cloud platform, and then the output is stored in .cdf files, and it's made available to a TREDS data server, so it can be accessible and integrated in, for instance, QGIS or in other visualization software.
Exactly. So what we just saw Mohamed did was that he was combining some of the products from Sentinel, so a layer 3, I think, and then on top of that, even more processed data. So the information that you did with the algorithm on the NextGEOSS platform. So further processing, and you combine this, right?
Yes.
Yes.
Yeah.
And I think this is the case that you will see in many other application areas as well, that you have some more, different layers of satellite data from Copernicus, and then for your specific purpose, you have some algorithms, so you get some new data products, and you want to look this together and to get informed. So this is where the value of the data is really coming to shows up. So this is a very simple. It's simple. I guess the devil's in the detail, Mohamed. Huh? How much time did you spend on learning this tool? Would you say?
For me, I have been working with these tools since long time. As I said, I started with Map Info for the people who know that, and then I have been using ArcGIS, and I think still people using it a lot, but that is more commercial software by Azure. But now I'm using MOS here, but also we develop our own script here for processing, especially for SAR data and for remote sensing data. We use Python, and we have a complete package for image processing that we call it NANSAT here at NANSAT Center.
Right. So you have been working on that at an advanced level for some time, Mohamed.
Yes.
But it seems to me, so from this introduction here, it seems that you can start with simple illustrations using some of the data sets, just combining some of the simple ones, and then you can also use data from or data products from NextGEOSS. And I think this is a NextGEOSS data webinar, and it just shows that using the NextGEOSS data hub makes it easier for you to find the data. So finding the data, right, is one of the things that you showed to us that you could do.
Exactly. One of the things now, what is happening now, in the past, before the Sentinels, all of them are out. Data is scattered here and there, and few data. You can work with one image here, one image there. You have MVSat. It went down, I think, earlier, and you have RadarSat, that's for the SAR part. But now you have Sentinel. They have, I think, 4 or 5, and in each one they have 2. Besides the other data you have already. So as you said, for NextGeo, if they have a big catalog which is collecting a lot of data, so it's so easy to go to one, and just like CMEMS and all this, so a lot of information available there for the people who are interested in processed product, higher level product, a little bit. So you can get product directly, and you can combine it with any other information. You can combine it with also data that you have your own data. Your own data, you collect it yourself on the field or something like that. You can try to plot it on the top of it and make your analysis.
Okay, so we have a question from Gabrielle. What is the difference between ENVI and QGIS? ENVI.
Yeah.
You know it? Yeah.
Yes. Okay, I will try. I will not. According to my point of view, all software available now for image processing or for geographical data, you can define them into 2 parts, or you can put them in 2 categories. One of them is raster based, and one of them is vector based. Or what I mean, when I say vector based, the vector based is dominated. Like QGIS and ArcGIS, they recently start to introduce image processing packages inside the software. But for ENVI, I think, personally, I think it is more for raster processing. You will find less functions for geographic or for vector processing in ENVI. ENVI is also a very good software for image processing, and that is the same like Ardas Imagine and this software. So that is as far as my personal point. But it would be nice to hear from Gabriela also about what she think about that.
Yeah. So ENVI, is that free and open source as well? ArcGIS is no. Okay, ArcGIS I know is behind.
ArcGIS,
you have to pay for it.
Is commercial also.
Yeah.
You have to pay for that.
So in the Earth observation community, where I have been a member since many years, I've heard about ArcGIS so much. So it's a very frequently used tool, but as you say, you have to pay for it, and it's rather expensive as well, I guess. So QGIS is, and again, I heard about that as a free open source, and very popular in the open data and open source communities. So I heard a lot about it. So that's why I was very happy that we could offer this webinar, by the way. Let me see. Thomas is asking how to get the information on the percentage of sea ice cover in different grids. In other words, in 4 geographical grids, latitude and longitude around Svalbard.
I mean, like personally, you will not, unless you want to calculate it, then that you need to develop your own algorithm based on the algorithm that you used for processing this. Because I mean, they are two now. They don't process it. No, first of all, they don't process it for high resolution data. They process it usually for passive microwave, and that is the data you can find it anywhere, like showing the ice height. But for this ice concentration around Svalbard, I think the best product I personally advise is the one from METNU.
Okay.
Meteorological that they produce, I think, daily ice chart for ice concentration along Svalbard area with very good resolution. Besides that, also, I mean, it is based on a lot of other satellites.
Okay, yeah, thank you. Usama asks, aside from the graphical representation of data shown here for classification purposes, can we do some quantification operations on the data, for instance, statistical analysis for detailed studies and advanced research?
I think so. You just need to search for that. And I think if you, as Torill mentioned, there is a lot of people working. If it's not exactly you find it there, you can find some plugs that they can offer something like that. Otherwise, you need to think about how to develop that. And I think there are a lot of people cooperate in that because it's open source and you can write it in different programming language.
Right. So
they have quite
go ahead,
extensive training manual also on QGIS.org or docs.qgis.org. And they have separate modules, and two of the modules are, one is on vector analysis, which mentions also different kinds of statistical analysis, and also for raster. So they have some examples online that allows you to sort of play with what is in the tool. So I think if you have a look also to the documentation, you should get some idea what is possible to do. So I'm just looking at a few. They are calculating hillshade. They are calculating slope. They refer to something called the raster calculator. I didn't get quite that far in the training material, but I think there is quite a bit of functionality also for doing some processing of the data. And this gridding of, for instance, sea ice cover, you could get sea ice cover products from different sources, but maybe you want it in a different resolution. So maybe you would want to average and combine to calculate it at, for instance, to ingest the data into a model or to compare it with a model. So
that sounds like a research.
Yeah. So I think there is a lot of opportunities with QGIS. Of course, to get beyond the basics, where I think both Bente and myself are. I'm maybe a module ahead of you, but not not that far ahead. Then you need to do a little bit of digging, but I think there is a lot of possibilities with what is provided, sort of together with the core components. And then there's also a very active developer and user community for QGIS. So there's a good chance that you would find somebody who will have had a similar problem, has found a solution, or somebody that will help you to find out how can I compute the statistics on my raster data or my vector data, and how can I then present it afterwards in QGIS.
Yeah.
Because
also,
QGIS
I think you can
reads
just,
a lot of formats. So
if you don't find it there, if you find a script already written, for example, go to GitHub and something like that, and somebody has done that, you can hack it directly to the GitHub, you can to QGIS and see just how you want to do that. And by that way, also you learn how to change script already available or open source, like something like that, and how to change them to save what you want or save what you want directly.
Yes, so there's two things I want to add. So first of all, Torill, you mentioned that there's, you go through the manual. So what Mohamed have made for us, and Torill, I guess, is actually a description of how to, in more detail, right? Yeah.
These
So
tutorials are available, yes.
yeah, as a tutorial, he has made a full tutorial, and we will post this on nextgeos.eu. I just wrote the address for the web page. So if you can subscribe to our webinar series, and then you will get updates there, of course. But you can also go, if you're social media, follow us on Facebook and on Twitter in particular. We are active on Twitter. You will get the announcements on when that article with the more detailed description is available on the website, and it will come with this recording. Well, of course, since you have registered here, you will get the recording in your inbox rather immediately, very shortly after the webinar. But in addition, we will edit the video so that you just get the educational part of it in that article on the nextgeos.eu. So you will get like a proper tutorial. It will also be listed in our Learn. This is sort of a early warning that we will have a new how to part on the menu called Learn, where we have lots of educational material, not only the QGIS, but the QGIS will be very detailed. It was like you click on this, very detailed, right, Mohamed and Torill?
Yes.
It will be very detailed description.
For the tutorial, yes, it's step by steps. I mean, for whole what we have done here, it's step by step from the beginning, and also the how to log on these catalogs, how to make your username and password to register, step by steps. We make it on this tutorial.
So it's both QGIS and actually how you can also use the data, the NextGEOSS data hub, and find the data there, and also find it on CMEMS, on the Copernicus. Yes. So it's a full package. So we are very happy. We're very happy with that. Okay, and then I see. Thank you, Thomas and Darius, for sharing links to more CIS data on other sources. Thank you very much for that. So Anastasia is telling us that she's combining QGIS with SNAP by ESA, so the European Space Agency, which is also open software focused on Sentinel imagery processing, but it supports also other kinds of imagery in the process instead of, for instance, NVN or ERDAS, Imagine, which are commercial software. So thank you for being with us. Yes. So
I agree with that, because also, I mean, like for SNAP, it's not because it is the nicer part about SNAP, you will not find the same kind of tools, because especially for the SAR part, you will not find them in ERDAS and MV, the tenth of what is available by ESA, because that's just ESA software. So it is really oriented for their satellite and some similar satellite like RadarSat and other satellite from other places.
Yeah, and I want to add one more thing, actually. So open source, mentioning open source. So for the cold region in particular, so polar region, it's extremely important to have transparency. It's international waters. It's of high political interest. Having transparency at all level is really important. That's another reason why QGIS is a good tool to use, because it's completely transparent. So that's another argument, another aspect of this, I think, that has a special value for the polar region, but that is also the case for many other regions and many other topics. We heard about people using other types of data, forestry and land use, environmental issues. So it's transparency in some cases are extremely important. Not always, but in some cases really important. Yes. Did I miss something? I'm just wondering if I try to follow, have my eyes everywhere I look. So somebody is Luan. We were asking you what type of data you were using. And Luan, he says he's working on satellite data, including Sentinel-1 and 2 and Landsat. Yes, that's a good example, I think. Yes. And land use classification combined with machine learning. Exactly. So machine learning and artificial intelligence is really important. But that's what you used in this case as well, Torill, right? It's an artificial intelligence running into.
Yeah, for the CIS classification, we also used machine learning techniques. So that's
yeah.
So you see, this is where you can represent and present the results from this. And again, coming back to your example here, we know that the dynamics of CIs is of course important for real time, or almost near real time, as we say. But also we have specialist researchers that are interested in the long term. So Torill mentioned it briefly, but climate change, and the link between climate change. So in this case, the sea ice edge as one of the parameter defining climate change, and how that is related to policy development. How we are using the area, in this case, the Svalbard area and the polar region. I don't know, if you come from the other side of the world, you're maybe not so familiar with the policies and the sensitivities around the polar region, but let me say that in Norway, as an oil and gas country, we are in constant political discussion on actually where the sea ice edge is, and it has implications on how the policies for gas and oil. Just to mention one example of how important this little example from Mohamed and Torill is. So
yes, I think that's two cases. One of them in installation in open water, which is platforms. That's really important, where they should be and where the ice is. And the other thing, as I mentioned, navigation. And the third thing is also the environment, where like the Torill friend, beside Torill there, they are suffering a lot when the ice is changing a lot. And I mean, I have been there one time. There are 17 of them, because really this is their area. I mean, the sea ice.
Yeah. Exactly. Yeah. So there are many applications. So and visualizing is, and having information easily accessible using QGIS is what you just witnessed today. And I think so. If you please also subscribe to the NextGEOSS webinar series. We are planning on having several of these types of webinar. We might come back with more material from the Nansen Center here. Mohamed and Torill is working for the Nansen Center, the Nansen Environmental and Remote Sensing Center, I think is the exact name.
Yes.
We call it the Nansen Center.
Yeah.
And I will also like to plug maybe so everything to do with ocean. So sea ice being a part of the ocean here is highly relevant. So I foresee that we will come back with more tutorials and more webinars on that, because we are entering the decade of the ocean. It's the UN decade of the ocean. So I think that's definitely coming up. And we see that there are many here that using land cover, are interested in land cover classification and so on. We know that this is also a topic which we are also covering in NextGEOSS, by the way. So cold region is one of the pilots. So you can say one of the best practices of using the NextGEOSS data hub and platform, but we have several others as well. So biodiversity, other ocean related pilots, food security, disasters, you name it. You can go to the web page and see different practices, best practices. You can see it on the bottom of the front page. And do not forget to subscribe to the webinar series. You will get a reminder in your email about the webinars coming up. And you can tell us what you want to hear more about. As I told you, we are covering so many of the areas using data. And we have our data hub, excellent data hub, and many people that can teach us how to use it. Okay, thank you. Thank you, Gabriel, Abdullah, Osama, Anastasia, Darius, Thomas. The list goes on. Thank you so much for attending us. And we hope to see you again. Make sure that you follow us so that you can get the fine, detailed, step-by-step tutorial that Mohamed and Torill has made. And until the next time. Bye-bye.
Bye-bye.
Bye.